Hello everybody and welcome back to another video on discovering code. आज हम टैकल करने वाले हैं एक और very good problem. I don't know if it's very good but it looks pretty good, and the marking for this question in code forces is given as DFS or similar, DP, uh, greedy and everything. So let's try this problem out. Let's see ये हमें क्या सिखाता है आज. And yeah, if you like this type of content, let me know. I'm just here to learn, just trying to document my journey as I move along. But yeah, मेरे दिमाग में एक और thought आया था कि maybe I could also record the video, like do the problem first, learn from it, and then create a solution type video. But those type of content is already readily available, and besides, I like to watch myself struggle. I mean, not like that, but you get the point. Okay, let's read the problem. It is given a positive integer n in one move. One can select any single digit and remove it. One selects some position in the number and removes the digit located at this position. Okay, कोई random position select कर सकते हैं हम, right? So one selects some position in the number and removes the digit located at this position. The operation cannot be performed if only one digit remains. Acha, okay. So if, oh my god, that's too thick. I'm not gonna say it. N is equal to 1 stop. My god, or you know what is better अगर मैं type करूँ rather than writing. I think that's better. If n is equals to 1 stop. Great. What's the next observation? Okay. And the next is, if the resulting number contains leading zeros, they are automatically removed. Leading zeros as in 0, 0, 1, 0, something. तो ये 0 गायब हो जाता है. 0, 0, 1, 0, these zeros will be removed. If one removes from the number 3, 2, 9 to 5, the third digit, if we're taking this, then it will be 9, right? The resulting number will be 3225. If one removes from the number 200999050 the first digit, so we remove 2, we have two leading zeros, we'll remove that, so our ending number will be 99050. What is the minimum number of steps to get a number such that it is divisible by 25 and is positive? So we have two more conditions. Minimum steps require, sorry, we have to add if any leading zero, then it's removed automatically. We don't have to deal with that. We can return 0090050. Okay, and the things now, these are the things that are given to us. Let me solve it like a proper math problem, like in the good old days. Given is this. Now what is asked is find min steps to get n sorry, actually this to make two minimum steps to get a number from input n that is divisible by 25 mod 25 is equals to 0. And the other thing is that This number should be positive. Okay, given that guarantee है हमारे पास, guarantee, is the spelling correct? I think so. Guarantee that the number n as, okay, it is guaranteed that n has such an answer. Okay. Uh, okay. Can I make this smaller? Bring this here. Can I increase the size of this? Much better. So let me remove that. No, not that. Brilliant. Okay. Have I started the timer? Okay, great. Okay. So what are we thinking here, guys? What are we thinking? I mean, it looks kind of okay. Let's do one thing. Let's analyze the time complexity. Okay. So we're given 1 second. 1 second is, I think, roughly 2 into 10 to the power 4 ops. Let me do a quick search on that. 1 second represents how many ops in programming. 1 second is 10 to the power 16. Sorry, not bad. My bad, my bad. It's from Code Forces itself. Okay, it is in CPP, it's close to 2 into 10 to the power 8, but in Java it should be a bit slower, right? Java, what's the max ops that can be done in 1 second? Okay, simple operations can be done 10 to the power 7, 10 to the power 8. Complex operations, functions, object creation, hash map lookups, etc. are 10 to the power 6 per second. Okay. So let's take the boundary as time complexity. Per test, we can do 10 to the power 6, and we have number of tests that are there are 10 to the power 4, which is roughly 10 to the power 10. So okay. Okay. 10 to the power 10 means we can only have a solution that is around O of n or O of 1. Okay, so this is our limit, right? 10 to the power 10. And so we cannot exceed this time limit. Now, As we know, O of 1 is instant, it doesn't take anything. O of log of n complexity takes 1.7 roughly into 10 to the power 5. That's a percentage sign, 5 operations. O of n solution takes 10 to the power 5 solution, sorry, time, number of operations that it can do in this much time. O of n into log of n, this solution takes somewhere around 1.7 into 10 to the power 6. And then O of n into n solution, this takes roughly around 10 to the power 10. So we cannot do this. Anything above that, I think we can. So this is okay, and likewise. All right. Mm, 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 mm. Now we know that since we could do this, all right. Okay. Mm, 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 mm. Now let's focus on our solution and solution. Let's see. Let's walk through an example. We had, okay, let's read the input, how the input goes. So we are to take each test case consists of one line containing one integer n, which is from 25 to 10 to the power 18. Now 10 to the power 18, that means we have to use long. We cannot go int, since we, like, I don't think 10 to the power 18 can it be stored? I think 2 into 10 to the power 8. What is the big in size limit? So it can store somewhere around intent power. Hmm. So we cannot use the 32-bit integer that we call uh, so the normal int that we use in Java, that is a 32-bit signed integer, and we cannot use this since it can only take up to 2.14 into 10 to the power 9 uh, value. And so we have something called a 64-bit integer. Bit integer in Java is called long, and it can store up to 9.22 into 10 to the power 18. So safe. So input will be long. Okay. All right, let's decode it further. It is guaranteed that for each n occurring in the input, the answer exists. We have noted that down. It is guaranteed that the number n has no leading zeros. Okay. Uh, for each test case, uh, output, a separate line, an integer k, which is greater than or equal to 0, because the answer should be positive, the minimum number of steps to get a number such that it is divisible by 25. Mm-hmm. Okay. So we have to do division, right? Need to check if it's divisible by 25. We can remove the digits 1, 3, and 4 to get the number this. Uh, okay. So I can understand why DP was listed because I don't I think we could do greedy as well. Uh, but how will we do greedy? I mean, DP should be straightforward because in DP we will be searching through every single uh, possible answer and obviously optimized DP. So through uh, memoization or tabular method, we could get some answer which will be divisible by 25 and positive. But how could we do in a greedy method? Uh, because this is a 900 rated problem, I think we should look through greedy first, and obviously, if time permits, we could also check DP. But let's see. Let's walk through a whole example. So right away, what we can do is check if input is divisible by 25 right away. I think if it is return input, think this is a mandatory check that we could do. One scenario, like it's directly divisible, so we can just return it as stated here as well in the first line in the note. It is already given that the number is divisible by 25. It's also given that the n will be greater than or equal to 25, the lower limit. So no need to add a check where the 25, n is less than 25. In the second test case, we cannot remove the digits. We can remove the digits 1, 3, 4 to get the number 75. 1, 3, 4. Okay. Mm-hmm, mm-hmm. All right. How did it identify that we can remove 1, 3, 4? We are not given any. Yeah, okay. We can remove as many as we like, right? And we cannot do the operation if only one digit remains. Okay, great. Mm, 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 mm. Okay, let's try it out. 7, 1, 3, 4, 5. How would the algo go? Actually, let's leave the algo aside. Let's check how would we solve it as humans, not as a computer. Let's look it through the human eye first. So what I'll do is I could try dividing the whole thing by 25. Uh, will it divide? If it leaves a remainder, then what we could do is then we could modify to divide by 25 actually. We either in the last bit we either need a 5 or we need a 0. This is a prerequisite. So uh, okay, minimum number of steps at 23, right? Because I think 25, right? 25, 50. Okay. Okay. Mm, 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 mm. 135. Does 135 belong? 25 into 5 is 125. Yeah, 125. It doesn't. Okay. So I was okay. So that gives me an idea. We could build from the back. We could check 45. Does that build? Or doesn't build? Okay, we leave it. Does 30? Okay, 35 is literally smaller than 25. Sorry, does is smaller than the second. Um, uh, like 25 into 2 is 50, right? So anything less than 50 and which is not equal to 25, we can reject. 145 is not there, 135 is not there. Okay, that but that is the brute force method and that will require n square. And we just discussed that n square is literally not possible. So, hmm, how would we do it in greedy method? Um, mm, 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 mm. Oh shit, my bad. How do I remove that? How did it pick 7, 1, 3, 4, 5? Mm, 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 mm. Mm, 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 mm. Okay, 25, 50, 75. All right, I think I see a pattern here, guys. So we are provided that our n will always be from 25 till 10 to the power 18, right? But the scope of our problem is that we need to find numbers that are divisible by 25, correct? So why do we give a damn about the numbers that are not divisible by 25? So, and another point is that it is provided that our input will always have a guaranteed answer. And uh, uh, it's also provided that we only have to remove certain digits to find the answer. So it's always provided that we'll have a permanent answer. It's always provided that the input will contain, sorry, we only need to remove digits from the input, and it's also provided that mm, the answer exists so that that answer is divisible by 25. So I wrote down the table of 25 till 200, but I saw a pattern here, which I think we can use in the inputs to observe something. Any number that is divisible by 25 must end in 5 or 0, correct? But now another thing is, any number that is divisible by 25 must have only these four pairs of digits: 25, 50, 75, and 00. So if it ends in 00, like you can add 2, 3, 2, 0, 0. You could add anything like 1, 0, 0 is obviously divisible. 0, 0. So like it should end, if it ends in 0, 0, not leading by the way. So 25, 50, 75, and 0, 0 with something ahead. It should not be leading. These four, if they are present in our input, then we can say that could be the place where our answer exists. Now we need to minimize the number of operations, right? So we need to find a number that contains one of these four pairs, and we need to find the numbers that are obstructing this number from getting, uh, I mean, which are obstructing the number so that we are unable to divide it by 25. So we need to remove those numbers. So we just need to count up those numbers that are in between a pair and a number between those pair, uh, which allows us to still divide by 25. So, okay, so let me rephrase it. What I'm trying to say is, uh, let's say we have a number A, we have our pair 25, And let's say we have B and C here, right? Now A is not just a single digit, let's say it could be 3 digits. We need to identify such numbers that when paired with with our pair that we have identified still allows us to divide by 25, and we need to remove such pairs that obstruct, or which numbers that don't allow us to divide by 25, we just need to remove them. Once we remove them, the whole number becomes divisible by 25. So that is a revelation that I had by writing down the table and observing. Uh, all right, but we do still need to think about how are we going to do this process, right? Because we need to search up the numbers, and we need to try we need to first okay, let me just clean this up and write it properly, so that we can move ahead in a problem. Great. All right. Let me just go here, click here. All right. The only pairs that only divisible are zero, non-leading, second 25, third 50, fourth 75. Okay. Identify the pair, then find the digits that obstruct from creating a number using this pair, which is 5, return the such digits. Okay, so good progress. Let's keep going. All right, so I think I've figured it out. We could use 2 pointers here. 7, 1, 3, 4, 5. So since we only have 2 pairs that we are looking for, this is non-leading by the way. 25, 70, sorry, it's not 75, 50, 75. All right, so what we could do is we could do each pass for each of uh, the number that we have, and we could check. Okay, 5 is here, so these two will mostly return something, but we could find the minimum number of operations required. And if we don't find anything, it will return -1, right? Or no, not -1, actually integer dot max, because we are trying to minimize here. So 75 will find this, and then this. So this is a hit. So it will return 3. And these will return max value, right? So from max and 3, this will give us 3. And how it will go from right to left, and we will keep 2 pointers that will point here. The first pointer will look for the first pointer will represent the ones digit, and then this will represent the tens digit, right? We will first search with the ones digit. Once we find the ones digit, it is guaranteed that the answer is there. So once we find the ones digit, then we'll start moving the tens digit. Once we find the tens digit, we will calculate how many unique numbers that we had with our ones digit as well as our tens digit, and then we will return that number and from all the collection of these four we will return the minimum of whatever we got, and that will be our answer. So this will be our very chaotic answer. And so let's try to code this up. uh Give a moment, I'll just make this a bit more cutie cuter cutie, I don't know. Okay, so I have made it a bit cleaner. As you can see, the ones was stuck at 5 for the 75 iteration, 75 number iteration. One is stuck at 5, then we iterated, and if it's not 7, we just increase our count. And once we reach that 7, we return the count, and the count is 3, and the 3 is printed. So, all right. So that's the thinking part. Now let's code this up, shall we? I have a template for code forces in installed already, set up in my VS Code. Let me just remove this. All right. So our first business is to, sorry about that. Sorry for the burp. Our first business is to take input, and our input is n, right? Okay. And n is equals to sorry, long. This will be long, we just discussed. Uh, and then we have, that's it. That's all we have to do for the input. Now what we can do is, I'm thinking we could initialize an array of say digit or something. Oh, how do we do this? We could do four pair, four. Uh, what can we do? What can we use? Something, I want to use something like this, so that 7,5, something like that. But that's a 2D structure, and I don't want to use a 2D structure, because then to access it I have to use two loops. But okay, I'm thinking. Since we only have 4 values, that should be pretty straightforward, right? That should be of one operation. Even if we have two loop, for nested for loop. Okay. Two loop. Nested for loop for a 2D structure that will contain our target pairs. How does that look? Yeah, I mean, that should do the trick, right? And target pairs is equals to Okay. Yeah, let's do a for loop for, or maybe we could do it in one loop if we can convert uh, 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 mm, mm, any currents that we have. Uh, 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 Okay, okay, okay. Uh, I think we could convert it all to strings. That's what I was thinking. Because otherwise we'd have like, how would we, to actually remove it, we'd have to do uh, division and remainder to actually remove the digit from the number to check it again. But as a string, we could do it rather quickly. But as a, I mean, it's a little bit more straightforward, I guess. So yeah, actually, let's just do that. Let's have int as answer. Could call this what can we call this? Steps required is equals to integer dot max value, as we discussed. And we can have something like store it in a character array. So we could create like something like this. target pairs, which is something like 0. Then we have 0. This must be non-leading, by the way. I just keep repeating that. 2, 5, then 5, 0, then 7, 7, comma 5. There we go. Now we have that. We could we need to also convert this n into a string, right? So string input is equals to long dot to string n. There we go. Now we could just get a pair from our target pairs, and then we could create a character for the left digit or the ones place, will be pair of 0, and character tens place will be pair of 1. Then our right index will always start at the back, right? Right index, or we could say right pointer. We could just call it right. Start last index of sorry. Wait, sorry, not S. My bad. Last index of steps required. No, ones place, because we're looking for oh my god, my bad. I did a very big idiotic thing. This will be tens place. This will be ones place. Thank God I realized it, because that was pretty foolish. NGL. And so this will be ones place. And we can say if we don't find a right, we could just return -1 and we could continue. Like if we don't find anything, this function returns a -1 if we don't find anything. So then -1 is returned, and if it's -1, we just move along nicely. Int left, which is our tens place. So last index of, we need to start in front of our ones digit, obviously. So this will be our tens place, which starts ahead of ones place -1. So sorry. Right, -1. Oh, why is it showing with that? Oh, semicolon. Okay. Again, my bad. This will be input. And if this returns -1, we could say just continue. And so our current total ops will be the total length that we find. Mm, the length from our right to our left, but we need to exclude the indexes that we are at. So this will be total length minus right minus 1, because the indexes are in, and they start from 1, but in Java it starts from 0. So taking that into consideration, and we have I think I did not, this will be input total length, and then this will be, let's visualize this actually. Mm, 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 mm. So this is the total length. So what we are doing is we are this is the total length, len, and then we find our ones index here, wherever we find it. Now it's here, so that's okay, but it's at the total len of it, correct? So this will be len minus 1, because this will be minus 1 as well, so this will return 1. I don't think I wrote it pretty nicely, but it is what it is. I'll show you. Len is the total length, right? But this is in one's index, right? One index. Now minus, this will be len minus 1. This is at len minus 1 and minus 1. So this minus 1 will be len minus 2, and minus of that will return us, give us 1, right? So that gives us 1, and we also need to figure out where are tens places, right? So this will only be smaller, so we need to find out how much distance between these two are. We know the distance, we know the location of this, we know the location of this. Just directly go right minus left, and minus 1 obviously. So that will give us these ones, and we can just add them up. That will give us our current op. Let me just erase all this, or not that. There we go. There we go. Not that. There we go. There we go. There we go. Actually, let me just do this much cleaner. So this will be right minus left minus 1. And then our steps required will be the minimum of steps required, comma, current ops, whatever we find, right? And then we can just out dot print ln steps required. There we go. Let's test this. Let's see if it works. I have my input here given already. So let's press play. Let's see if there's output. And I think it's the correct output. Let me just check real quick. 0 0 3 1 3 2. Great. I think it looks correct. So let's go ahead and submit this. Let me just make this. Let me just make this, because Codeforces doesn't accept that. So I think it's a pretty clean solution, but I'm not sure how well it's gonna do, but let's try our best, shall we? I'll just keep this here so that you can see. Choose file, this one, submit. Let's see. Did I save it? I did not save it. It's gonna fail. Yeah. Uh, I'll do it again. I need to enable autosave. Okay, let's see now. Uh, Great. Awesome. Incredible. So that was a great solution. I don't think I explained this line very well. Uh, but I think you do get the idea. What we're just trying to do here is like this is the total length, and then this is a much higher number, right? But we need to find out the difference between this and this. So to find out the difference between this and this, we first need to find out where it stands. Uh, because the numbers after it do not matter. The only numbers that matter are the number in between them. No, wait, that's not right. That is absolutely not right. It does matter. What is after it and what is in between. So what we're trying to calculate first is whatever is after it. Okay, that makes sense. I think I got confused as well. Here. Uh, so what we are trying to find out is this once this one that we have, this pointer is literally the last number, but it will not always be the case that this one will be at the last. So there might be some other numbers after it. So what we're trying to find is where is this, and then what's the total length that we have. If we remove from the total length the this length, we will find this length, right? So that will be added to our ops, which is what is being done. So this gives us the addition of the after numbers that we have. And then what we're trying to find is in between the 10 and the 1, how many numbers do we have? And that will also be added to the ops, which is being done here. And that makes the operations for that particular sequence. Uh, the number of the total number of operations that is required, and then we take a minimum of those total steps required, and then we return that. So yeah, that's a great solution, guys. I think I've taken much time for this, but that was a fun one to solve. I will see you in the next one. Until then, take care. Bye bye. Have a good night, day, afternoon. Live a brilliant life, and yeah, keep grinding. CP. Yeah, only CP. Thank you.